Hello, our project name is Efhamni. According to the World Health Organization, as of April 2021, over 466 million people of the world's population have hearing problems, and 34 million of these are children. In Saudi Arabia, as stated by the General Authority for Statistics, the number of people with hearing problems has reached 59,000, including 12,000 children in 2018. The hearing impaired people face many difficulties. One, there are over 300 sign language globally, and more than one Arabic sign language. And the Saudi sign language slightly differs from one region to another, and only about 28,000 of Saudi hearing people can understand it. Also, due to the lack of integrating school, over 17,000 of them didn't join the educational system. Three, isolation is a critical factor in mental health, as being hearing impaired increases the risk of depression by 30.5%. Saudi hearing impaired people face difficulties in fully integrating with the society due to the lack of tools that translate Saudi Sign Language into spoken or written Arabic. Our goal is to develop a mobile application that automatically translates Saudi Sign Language to spoken and written Arabic to help the hearing impaired community. To solve this problem, we propose that a hearing impaired person perform Saudi Sign Language gesture in front of a mobile camera as input to the Efhamni application that will result in the output of translated text and audio. Efhamni application has many features. Enable users to chat via QR connection, enable the user to save videos for later retrieval, automatic translation without the need for a human translator. Accommodate different user for different scenario. The project scope only covers word related to the healthcare sectors. The dataset we are using contains 80 signs, including 40 words and the Arabic alphabet and numbers, in total of 8,000 videos recorded by 40 people in uncontrolled environment with no restriction on the participant clothes, lighting, or background color. Contains both single-handed and two-handed motions. Based on our research, we have compared 13 state-of-the-art research approaches, which is illustrated in the following taxonomy. There are two approaches to translating sign language into text and audio. Vision-based approach and device-based approach, which we have excluded since they are out of scope. The second approach that we decided to follow has been applied in three directions of translation: sign language to text and audio translation in both directions, sign language to text and audio translation, text and audio to sign language translation.
We have compared 10 related applications to our project. This table shows 3 of them and compares them in terms of language, translation direction, dataset, platform, and their features. As you can see, they're all Arabic languages, and the first 2 applications translate from text and audio to sign language. But the last one provides the same direction as our project and translates from sign language to text and audio. But it operates with real human interpreters with limited working hours, so it's not automatic translation. We gathered our data by conducting 3 interviews with Saudi Sign Language experts and 2 questionnaires. The first questionnaire targeted the hearing impaired community, and the second was for sign language interpreters and people related to the hearing impaired community. The total results were 106 answers. We conducted 3 interviews with Saudi Sign Language experts with more than 20 years of experience And one of them is the president of the Hearing Impaired Association, and the other one is a teacher for hearing impaired students, and the last one was a sign language interpreter. Summary of the interviews, all of them agreed that it is a useful project and is qualified for a patent because the hearing impaired community are used to using mobile phones and recording themselves performing signs, and the differences in dialects are not an issue. And they advised us to use the Saudi Sign Language Dictionary, specifically words related to health sectors, and to meet hearing impaired people in groups of maximum 9 people to get the answers to our questionnaire.
System architecture design identifies the system's input, cloud processing, and output for Saudi Sign Language translation. The Saudi Sign Language translation system is implemented on an Android environment, and the input is an image or a video. If the device is connected to the internet, the image or video will be translated and saved in the database. Also, generate audio for translated text by using Google Text-to-Speech API. Then the user can send the translation to the other mobile if the account is connected to another account via QR connection. Prediction model flowchart shows the steps of model. First step is capturing the frames of a video by the video capture method from the CV2 library as BGR. Then convert the image to RGB to feed it into a built-in model from MediaPipe to extract key points. We have chosen MediaPipe since we are interested in hands and pose to detect the signs. After we extracted key points of pose and hands, we duplicated the dataset by taking the reverse direction of each video, then concatenating the two directions, resulting in a total of 32,000 videos. Then the dataset is divided into three groups: 80% for training, 10% for testing, and 10% for validation. Lastly, we fed these videos to the bidirectional LSTM model for classification. Our model obtained 99% accuracy in training, 94.9% in testing and validation. This is an example of the key points estimation that shows how the points are collected for the whole body and the face. Design. AR diagram shows the relationships of the entities in the database. The user entity has 8 attributes: user type, hearing impaired or hearing, full name, gender, birth date, phone number, email as primary key, and a password. Folder entity has 3 attributes: name as primary key, video ID, and number of videos, and so on. In addition, shows the relationships between the entities, like one user can have one library.
In our project, we used Flutter with Visual Studio Code for the development of back and front ends because we are already familiar with them, and Firebase for the database because it is easy to connect with Flutter, and Google Colab Pro Plus for the AI model. We have done the first 3 steps, which are coming up with the idea and planning, data gathering, and system design, and are currently working on the implementation part and will conduct the testing and feedback in the future. Our application is applicable because most people have mobile phones and know how to use them. Our AI model can work with any background and does not require a specific one. Signs are taken from the Saudi Sign Language Unified Dictionary, so differences in dialects are not a problem. Users can sign with only one hand, and the application is easy to use.
One of our application goals is to integrate hearing impaired people with the rest of community and reduce the difference in the lifestyle of the hearing impaired people because of this health condition. Efhamni application is economical solution compared to independent translation devices, which are categorized by their high price and dependence on sensor that may be damaged, which leads the hearing impaired people to buy a new device. Also, if Hamdi does not need new knowledge to use it because the hearing impaired people know how to use the mobile phone. This is a prototype of hearing impaired. This is a prototype of hearing impaired user interface. First of all, this is the main page of the app. Through this page, the user can register as a new user or log in to the system as a hearing impaired or hearing or guest user. It also contains info icon that will show the user a simple overview of the application. When the user chooses a register as a new user, the registration page will be appear, which will ask the user to enter a set of data such as a name, email, phone number, and account password, in addition to specifying whether he or she is a hearing impaired or hearing user. And this is a login page, which will ask the user to enter his or her email and password to take the user to the home page. The home page contains three main options. The first option is open the camera, which will enable the user to take a picture or video of himself and editing the video if the user wants. The sign language translation process will start and display the result on the translation page. The translation page will enable the user to play audio, modifying the translated text, save a video in the user library, or share the video. The second option is open the studio to upload image or video from the user device with the possibility of modifying the video to be translated and displaying the translation on the translation page as we explained before. The third option is open the chat, which allows the user to open a conversation with another registered user. A camera will open to scan the QR of the other user and notify the user if the scanning process is unsuccessful. The hearing impaired user will start a conversation with another registered user to send the translated text as a message and receive a reply. The user can also take a picture or video or upload it from the device from this page. The home page of the hearing impaired user is also contain a side menu containing the QR icon, which display the user QR, and the side menu contain the user library, which his or her videos are saved. Also contain the setting and how to use the app page. We faced many challenges during the project stage, including the lack of research on Saudi Sign Language and diversity of delegates of the sign language itself. Also, the difficulty of distributing a questionnaires among hearing impaired people due to this isolation of this group, and the difficulty of reaching them, especially during the current circumstances facing the country due to COVID-19. One of the biggest challenges we faced is communicating with the hearing impaired people to understand their needs and the difficulties they face to accurately determine the scope of the project. Also, we faced difficulty to find data set that cover the scope of our project, and then we find a King Saud University sign language data set, but we waited a while to obtain the transfer agreement. Thank you for listening.